Okay, welcome to the class. So today we have a new topic, operation on rational number, and this is from class 8 syllabus. So operation on rational number. First one, the closure property. According to this property, the sum of any two rational number is always a rational number. That means if a and b two rational number, if a and b two rational number, then the sum of a plus b is also a rational number, okay. That means when sum of two rational number, if a and b are two rational number, then the sum of a and b, that means a plus b, is also a rational number. For this we can take example, say a equal to 1 by 2, okay, and b equal to suppose 3 by 5. Clearly a and b both are rational number now. So a plus b, that means the sum of a plus b, that means 1 by 2 plus 3 by 5. What you'll get? Simply take the LCM. 5 into 2, 10. 2 divides 5. 5 divides 2, 6. That means 11 by 10, which is also a rational number. Therefore, the closure property is exists for sum of two rational number. Okay. Next one we have commutative property. Say example, I am taking next commutative property. Similarly, consider two rational number a and b, two rational number. Consider them two rational number. Now what will happen? Now a plus b, according to this commutative property, a plus b is always equal to b plus a. A plus b is always equal to b plus a. For example, say we have taken suppose a equal to 1 by 2 and b equal to 1 by 3, two rational number. Okay, now a plus b, that means 1 by 2 plus 1 by 3. We get 5 by 6. Also for b plus a, say b plus a, that means 1 by 3 plus 1 by 2. This time also we will get 5 by 6. So in the both case we can see that a plus b is equal to b plus a. That means you can say a plus b equal to b plus a. So this commutative properties exist for sum of two rational number also. Thirdly, we have associative property. This is known as associative property. Okay, so for this property, that means what? If a, b and c are three rational number, if a, b and c are three rational number, then what will happen? Then a plus b plus c is always equal to a plus b whole plus c. According to this associative property, this is the condition. Okay, so for that we can take, suppose say a equal to, consider any number 2 by 3, say a equal to 2 by 3 and b equal to, suppose we have taken b equal to say minus 3 by 5 and c equal to say minus 3 by 4. Now a plus b plus c, that means 2 by 3 plus minus 3 by 5 plus minus 3 by 4. So what you'll get, we'll get like here, the answer will be like 5 LCM will be 15, 3 divides 5 times 5 to the 10, so plus minus will be minus 5 divides 3 times 3 is a 9 plus minus 3 by 4, or you'll get 1 by 15 plus minus 3 by 4, or simply 1 by 15 plus minus 3 by 4, or simply you will get the LCM will be 60 and 15 divides this how many times? 4 times, and 4 divide this how many times? 15 times, so minus 45, or simply you will get minus 41 by 60. Also a plus b plus c, for this a plus b plus c we can write like that, 2 by 3 plus minus 3 by 5 plus minus 3 by 4. We have arranging them like that, then 2 by 3, or you can take here LCM as a 20, or you will get here minus 12 and minus 15 within bracket, or 2 by 3 plus minus 27 by 20. Again in this case, if you are taking the LCM, you will get 60, and what you will get 60, or simply here you will get 60, then it is 40 minus 81, or minus 41 by 60. So here clearly you can see that when we take a plus b whole plus c, a plus b whole plus c, this time we are getting minus 41 by 60. Also when we have taken a plus b whole, a plus whole b plus c, then also we are getting minus 41 by 60. So the associative properties exist for any three rational number, okay, for addition. Next we have additive identity. The question is, what is additive identity? Many of us have the doubt, what is additive identity? It is nothing but what? When 0 is added to a rational number, it leaves the rational number unchanged. That means, suppose we are taking a rational number, say 1 by 3. If we add with 0, this time also we are getting 1 by 3. That means when we add 0 to any rational number, we are getting the same rational number. Okay, and this is known as additive identity. That means that 0 is the additive identity element for addition of rational number. So as when we add the 0, we get the same rational number. So we can say that 0 is the additive identity element for addition of rational number, this is called additive identity. Okay, if we take any other number, like say any number 5 by 6 plus 0, this time also we are getting same number 5 by 6. So this is called additive identity. Next we have additive inverse. So what is this? When two rational number is added, suppose a and b, two rational number, a and b and two rational numbers, then if a plus b will get 0, when two rational number is added and we get the 0, then the each number is called the additive inverse of each other. That means here a is considered as a additive inverse. A is considered as a additive inverse for B, and similarly B is also considered as a additive inverse for A. So for that we are going to give an example like that. 1 by 5. Okay, when we add 1 by 5 with another rational number, suppose minus 1 by 5, so we will get what? 1 by 5 minus 1 by 5, or 1 minus 1 equal to 0 by 5, or you can get only the number with what? 0. So here it is what? 1 by 5 is the additive inverse of minus 1 by 5. Also minus 1 by 5 is the additive inverse of 1 by 5. Okay. So next one we have property of subtraction of rational number. Earlier we have learned about addition of rational number. Now we are going to find the property of subtraction of rational number, and for this we are getting, suppose like that, closure property. So closure property. Okay, same case, consider any two rational numbers, say A and B. Okay, so A and B are two rational number, then A and B are two rational number, then A minus B is also a rational. A minus B is also a rational number. Okay, so for this consider in common example, suppose like 2 by 5, A equal to 2 by 5 and B equal to say 3 by 5. Okay, so when we subtract A minus B, so 2 by 5 minus 3 by 5, and this time you will get 5 as the LCM, 2 minus 3 or minus 1 by 5, which is also a rational number, where it belongs to R. This is known as belongs to R, then which is also a rational number. So we can say that a closure property is exists for subtraction of two rational number. Okay.